Sugar crystals, maple syrup, and honey share a common theme. They're concentrated sunlight, captured and transformed by plants, animals, and people. This episode journeys through cane fields, maple forests, and buzzing hives to reveal the alchemy that turns sap and juice into sweet staples. In tropical cane fields, harvesters wield machetes and mechanical cutters to fell towering stalks. The cut cane rushes to the mill before sugars degrade. Rotating knives shred the stalks. Tandem mills squeeze out juice, while diffusers soak shredded cane in hot water, so osmosis can draw sucrose from intact cells. Clarification follows. Lime neutralizes acidity, and heat precipitates impurities, producing clear juice ready for boiling. Multiple effect evaporators concentrate the juice to a thick syrup, careful not to invert sucrose into glucose and fructose. In vacuum pans, the syrup becomes supersaturated. Tiny seed crystals provide nuclei for sugar molecules to gather, growing into sparkling crystals. The dense massicrete is cooled in crystallizers to continue growth. Centrifuges, spinning at up to 1800 RPM, separate crystals from viscous molasses. Raw sugar emerges, a concentrated narrative of nature and human ingenuity, ready for refinement or consumption. In cold forests, maples rest through winter. As spring sun warms the trunks, starch stored in roots converts to sucrose that rises in xylem sap. Tappers drill holes and insert spiles. Sap drips into buckets or flows through webs of plastic tubing. Each tree yields 35 to 50 liters of sap in a season, only a fraction of its stored sugar, and can be tapped for a century. Sap travels to the sugar house, where open pans and modern evaporators boil off water. It takes 20 to 50 liters of sap to make 1 liter of syrup, boiled to about 4 degrees Celsius above water's boiling point, until it reaches 66 degrees Brix. Reverse osmosis equipment can remove half the water before boiling. Operators add small amounts of defoamers, monitor density with hydrometers, then filter the syrup to remove sugar sand crystals. Hot syrup, around 82 degrees Celsius, is canned to sterilize caps. Further boiling can produce maple butter, cream, or candies. Hundreds of kilometers south, honeybees convert floral nectar into honey. Foragers swallow nectar into their honey stomachs and pass it to hive bees via regurgitation. Bees bubble the nectar between mandibles, evaporating water and adding enzymes. Teams of bees relay the liquid for up to 20 minutes, then store it in wax cells. Wing-powered ventilation maintains hive temperature around 35 degrees Celsius and removes water until the honey is only 15.5 to 18% moisture, halting fermentation. Once capped with wax, the honey can last indefinitely. Beekeepers calm bees with smoke and remove frames. In extractors, centrifugal force flings honey from combs without destroying them. The honey is filtered and sometimes gently heated to ease bottling. Enzymes like glucose oxidase produce gluconic acid and hydrogen peroxide, giving honey its acidity and antibacterial properties. Honey's low water content and high sugar concentration inhibit microorganisms, allowing the honey to preserve its concentrated narrative through time, granting jars a long shelf life when sealed. Whether cane juice spinning in centrifuges, sap boiling in sugar houses, or nectar evaporating in hives, nature's sweet alchemy is a story of concentration and preservation. Humans amplify what plants and insects begin. Next time you sweeten your tea or drizzle syrup on pancakes, imagine the fields of cane rustling in the wind, the quiet drip of sap in a frosty forest, and the hum of bees fanning their honey. Each spoonful is a concentrated narrative of earth, time, and labor,